Okay, good afternoon to everyone. Sorry, there was a delay. It's a computer thing. IT has its own positive and negatives, most of the time positive. Anyway, it's been a real relish and a joy to listen 2 days of presentation on a very topical theme. And I don't know where to thank and how to thank the organizers as well as the presenters. So 2 days we have heard about the problems with pollution, particularly synthetic material pollution, and then people are finding their own ways to reduce contamination, to conserve energy, to avoid water pollution and other pollution in our industry. And we are going to present here a solution to an important problem, one that has direct impact on environment as well as human health. And what all we heard since Dimitri speaking about microplastic pollution and then contamination in terms of dye pollution and other material pollution in the environment, we have been doing for past 4 or 5 years. In fact, prior to that, we started looking at how sustainable materials can be used to two things. One, protect the environment and enhance human health. So I'm going to present a story on how we are using sustainable materials to protect the environment. This work would not have been possible without the efforts of my doctoral student, Dr. Vineet Kumar Singh, and I'm going to present his results. He graduated and moved on, and he's making more money than I. So that's what professors want to do. So with that, I'm going to talk about an important problem, that is pollution in the marine environment. We are not talking about one particular pollution. We are talking about multiple fronts here. One, what happens when the marine environment is polluted by a toxin, and that too toxin is found to be a carcinogen. It's a crude oil, which is a phase changing material both in the liquid phase and the vapor phase. What happens to that? So far Dimitri spoke about one particular pollution, that is plastic pollution, whereas the industry so far have been using a synthetic material to counter a pollution which is carcinogen. In other words, when there is an oil spill in a marine environment, crude oil spill, we are not talking about a motor oil or a synthetic oil, we are talking about a crude oil. So the solution so far has been to recontaminate it. So the industry has been using a synthetic material, particularly micro melt blown, which is a very fine material, less than 1 micron size fiber. When we didn't even think about microplastic pollution, people have been using, and this has become fairly a standard to use micron and submicron size polypropylene melt blown non-woven to counter a problem which is a toxic oil. So we are going to tackle these two problems. One, pollution due to crude oil, and then avoid using synthetic material, that too micro melt blown material. So let's see how we are successful. Okay, so this is what happened, and much interest came in using sustainable oil absorbent just past decade alone. In material science, it takes minimum 15 years to transition an idea to a reality, lab to reality. But we have done, with a bit of luck, we have done that within 5 years. So we started putting more efforts right when 2020 Gulf of Mexico spill happened, and people are still assessing the carcinogenic efforts of it. So if you look at it, this is one of the greatest man-made disaster, I would say so, in the history of marine pollution using oil. So roughly about 4.25 million barrels of oil spill into the Gulf of Mexico, which was much more higher than the Alaska spill. So we are still worrying about the carcinogen effects of the Alaskan spill. Here comes the gift horse keeps on giving, and here comes the largest spill in a man-made history. So this is what it is. So far, what have been people using? People have been using booms to contain, then skimmers. These are mechanical countermeasure materials, sorbents. I'll leave that aside for a minute. And then people have been using dispersion. When you use dispersion, they are again repolluting it. So you are pushing the can down the road from one particular aspect to another particular aspect. Then in situ burning, that is again pollution. Then other things are happening. These are all basically mechanical. So booms are necessary, skimmers are necessary, and sorbents. What types of sorbents? prior to we putting much efforts and we promoting it in terms of outreach efforts, talking about the issues with micro and nano meltblowns, people have been predominantly using, because this is because the industry wants a cheap product, and there's nothing else that could replace polypropylene, which is one of the cheapest synthetic material. Are we successful? That's what I'm going to show. Okay, so we are going to only focus on oil sorbent, that too sustainable oil sorbent. How can you push sustainability? This is the question I've been asking the great speakers who are better educated than me, intelligent than me in the subject they speak. But this is the issue which the industry wants. They want a solution which is environmentally friendly, but they want it cheap. This is kind of a dichotomy here. They want a material to tackle the pollution issue, but they don't want to pay for it. Who is going to pay the cost for it? So what we decided was, okay, we want to take some sustainable material as a sorbent. Okay, there's so many sustainable materials, but at what cost? At what cost the industry will buy the idea? The idea is great because we are not going to use plastic, right? So that's what it is. So idea work, there is a good science. We publish in ACS journal, which I will show, and we got press in Economist and all sorts of things. Outreach happened. But then there was inertia from the industry because they were not willing to pay the price. Of course, nobody can compete with synthetic material. We know that there are a lot of people from Cotton Incorporated, Renuka, I suppose, joined this morning. This is the thing which we face. How are we going to compete against a low-cost material? I'm not going to use the word cheap. How are we going to compete against a low-cost material, even though we are going to tell a good story? That's the problem, particularly in sectors like textile, commodity-based sector like textiles, automotive industry, and other sectors which deal with commodity products. Cost. So that's what it is. So one, we want to tackle an important problem which has direct health and environmental effect. That is toxic oil spill. Second, we want to use a sustainable material, there again avoiding the pollution. And third, are we able to deliver a product which is sustainable to tackle an important problem at a cost-effective way? So that third thing is what I'm going to focus. Okay, and I work in cotton, and this is what it is. Cotton is known to sink in water which has been bleached, or finished cotton is known to sink in water. The one you see on the right hand side, which is left to me, is an absorbent cotton. So when we decided to use sustainable material, everybody thought went to, okay, when we and other labs were doing, chemistry labs and others doing, which are not into cotton research. Okay, I go to a CVS or a Walgreen and then buy the absorbent cotton. And then Ram says that cotton is good. I put the cotton in water, it sinks. That's the important story. It is not the cotton which is used as a surgical gas or a surgical material. That cotton is costly. You see, I'm tackling the problem. So I'm going to give you a sustainable material. Of course, both these cotton which you see on the right-hand side and left-hand side are sustainable. There's no doubt about it. But the absorbent cotton is not for this particular application. It should not sink in water. It should phase separate oil and water, and it should only absorb the oil, toxic oil, but it should not be costly. It should be cost effective. Whereas if you go to a CVS or a Walgreen or or Costco, I'm not here advocating one particular shop or a retail giant here. All that people know, common Joe Blow know, is okay, I go to a cotton, get a cotton wool, and that cotton wool is expensive. Come on, you are kidding. You say that you are going to give a sustainable material. Of course, cotton is a sustainable material. People buy that. But this cotton is expensive. I'm not going to pay this. The oil industry or a natural gas industry or a heavy metal industry said to me that I'm not going to pay that cotton. There comes the solution. We are not going to use the bleached cotton or a finished cotton. We are not even going to use any mechanically finished cotton. We are going to use a cotton which the textile industry is not kinder to, and that's what we are going to say. I'm not going to use a I'm not going to use a finished cotton. I'm not going to even use the cotton which the textile industry uses on a regular basis. I'm going to use a cotton which is discounted. I'm going to use a cotton which the textile industry is not particularly interested in. Is it possible? So it's possible. That's what I'm going to show. And when you use a particular type of cotton which is relatively inexpensive, I'm using the term relatively inexpensive, And at the same time, 20% of the cotton grown, particularly this year in 2022, I am sitting in the hub of cotton production, and my lab is basically in the middle of a cotton field. 20% of the cotton grown in United States falls to a category called discounted cotton or immature cotton or low microner cotton. So many vernaculars we can use. These low microner cotton do not pick up dye well. They are not particularly used in premier products. They are blended. Of course, when cotton prices are high, people blend it. That's a different issue. So we have spotted and selected a cotton where its immaturity is high. When its immaturity is high, I'm not going to show all the results, but I'm going to walk you through the story quickly because I've been given only 30 minutes and I have a demonstration to do. So bear with me. We'll run in the 5th gear. So I'm going to use a cotton which is relatively inexpensive, 6 to 7 cents per pound discounted. 20% of United States cotton fall under this category. Textile industry, particularly dyeing industry, is not particularly favorable of using this cotton because it leads to white specks, particularly in denim. So we are finding an added advantage, an added application, a high value application to a cotton, where we are using a cotton, we are using a raw material, where we are saving the price of a raw material. We are finding new markets and new application for a cotton, and that too in healthcare markets and environment markets. So the margin of the end product will be higher. The cost of production will be lower because we are using a raw material which is already discounted to 6 to 7 cents. So you see the story. Now we'll run to the history. So I'm going to use a raw cotton. What type of cotton I'm going to use? So this is what it is. Why cotton? I told you cotton. Cotton is a sustainable material. So far, the oil absorbent has been cheap material, which is polyolefin, carbon, hydrogen, right? Cotton also has carbon and hydrogen, but the added advantage is cotton also has 3 oxygen groups. So why cotton? Cotton is sustainable. And what type of cotton? That's what it is. So I'm going to use a cotton in the raw form, but that cotton is immature. And we found that if it is immature, it's a good Lord's gift to an immature cotton, is that it has higher wax content compared to normal base range cotton, which is 3.4 to 4.8. If you are in the cotton trade, you know this. I'm not going to go in deep into it. So lower the number, lower the microner, roughly around 3.4 and less than 3.3 up to 2.1 and sometimes 1.5. The cotton is finer because it is weaker, it is immature, less cellulose deposition. When the cotton is weaker and finer, it collapses. When it collapses, you can pack more cotton in a given area. When you can pack more cotton in a given area, your surface area is more. That's all we want. So the gift sort keeps on giving. We are picking a cotton which is 20% production on an average year. And when the summer is very hot during growing season, the cotton gets to be highly immature. So when it is having immaturity to that level, 3.3 and less, the cotton collapses quickly with less cellulose deposition. So it's finer. When the cotton is finer, that is the nature, it has to protect itself. So there is high wax and pectin deposition. So high wax, finer cotton, immature cotton, and the cost of that raw material is low. So the story unfolds in a beautiful way. So we are having a cotton where it is finer. So it collapses. So you can pack more fiber in a given area. Surface area is more. When the surface area is more, the first mechanism, surface mechanism, is adsorption, Adam and David. Then comes absorption. Both are good. Both are needed for oil attraction. And what did I say? That particular cotton is found to have 2 to 3% more wax at the fiber level compared to ordinary base range cotton, which the textile industry is very familiar. When it is highly waxy, it is going to repel water. So the polar attraction will be there between a synthetic product and a wax. Both are synthetic. So oil is synthetic. Wax is synthetic. These two attract each other, water repel. So that is what you saw in that video, that a raw cotton, immature raw cotton, will not sink in water. It will phase separate oil and water, and then it will absorb quickly and then hold. It will serve as a crucible. So what did we do? Our lab was the first one to throw light on crude oil. All the ASTM standards are all only meant for non-detergent based motor oil, but we have to show that this technology works in crude oil. Again, we use Midland, Texas crude oil, And the crude oil is, it has its own pungent smell. People cannot work in that environment. So we used all the safety precautions. So I'm going to show you the results on raw cotton, low micron or immature raw cotton absorbing the oil. What type of oil? This is a real crude oil from the field. Okay. And then we used all these methods to show the characteristics of cotton. I have to show that what cotton we picked is 3.3, and I'm going to show you results from 3.1 to 4.4. And then we used the AATCC TM97 method to show the wax content, and we got when we picked 3.1 micron cotton, the wax content was 2% more. Then we modified the ASTM standard to do the oil sorption method, and then we also characterized the surface area of a single cotton. So we could show that 3.1 and 4.4, the surface area of 3.1 cotton is much higher, so it will result in a Brussels result. So this is the method we followed. I'll quickly show you the method. What we do, we picked up about 2 to 3 grams of cotton. As you see, we have not cleaned the vegetable or bark matter there, because that is very important for sustainability. When you dump this cotton in the soil, these bark and other vegetable matter serve as a fodder, serve as a feeding material for the natural microbes. Natural microbes feed on the cotton, and then they eat the oil and they disintegrate the oil. So this is the method. I'm going to actually show you a product, and then I'll walk you through the results. So this is the method. We modified it. So now I'm going to pause this and I show you the demonstration. So Kim, would you tell me that if you are seeing the vessel I have, if you don't mind? I hope you are seeing the demonstration. Now you will understand more clearly. So this is, imagine that this is, I'm mimicking the ocean bed.
Slide. Is it supposed to be a video?
No, demonstration. Are you seeing my demonstration?
On your camera?
Yes.
Just barely. You need to pull your camera down some. Now you can.
Okay, so this is actually seeing is believing. So what I demonstrated, I'm going to show you. So assume that this is a ocean surface, and then it is dynamic situation. I'm talking here cotton. As you see, this is a raw cotton, and you can see the color. This is a low microner cotton, which is not the base range cotton. This is a low microner cotton. We have needle punched it. So when you needle punch it, delicately you needle punch it. So when you needle punch it, you rise the surface of it. There again, you create more surface area, and you can see the vegetable matter here. And as I told you, it is an immature cotton, so cellulose deposition is not good. So the color is yellow, right? Now, when I put this in the water and then I do the dynamic thing, you can see because of the high wax content, it's still floating in the water. It won't sink. Then set this aside. I'm going to now, I can't use without a fume hood crude oil. I'm going to show you a motor oil. This is a typical non-detergent motor oil. So I'm going to simulate what happens in a spill. Okay, this is colored so that you can visualize it. So we all know that density creates the phase separation and the oil comes to the top. Already this cotton has water in it, but you could see the water droplets as a dew drops on a lotus leaf. So the water has not sunk in, and I'm going to use the same material, and I'm going to dynamically mimic the environment. Still it is not floating. It will only phase separate on its own because of high surface area, because of high wax content and collapse nature at the individual fiber level. It will only pick up the oil and water will be left alone. You can see this. I didn't do anything. Instantaneously it does it, and water will drip. The first ever results. You can see how clean it is. And I am putting it again. If you take a terry towel and then you soak up water, second time it should sink. I'm not lying. You could see it's not sinking. The other surface will be still dry. I hope you are able to see this. Other surface is still dry. It's clean. Okay, so product works. The raw material is cheap. Raw material is sustainable, and we are not doing any processing. We are even leaving the barks and seed coat fragments intact. Okay. Now, are you seeing the slides? Okay, this you saw. Now I'm going to quickly see the results. Kim, are you seeing the slide now?
Yes, we can.
Okay, so now what did I see? So you have seen the method, you have seen what the logic is. I have thrown some demonstration to you. Now I'll quickly walk through the results. So the lower the number, the higher immaturity, higher wax, finer structure. So when you have a finer, so 3.1, now let's look at only 3.1 and 4.6. That's how the range is, 2 to 5. Okay, that's how the cotton range is. Let's not go into that. So whole world cotton falls between somewhere around 1.5 and 5.3. And what did I say? 20% of cotton, particularly years like 2011 and now, every 10 years, when the drought is so high, you may get 30 to 25 to 30% of cotton. If at all lucky, you will have cotton. 30% of cotton fall in the range 3.3 and below, which is no good. Our industry will not like that cotton. Okay, now I'm going to show you the results. Based on the logic and the hypothesis, 3.1 should give higher absorption, adsorption and absorption, but I'm going to use the word sorption. 4.4 to 4.6 is base range cotton that sells at 10 cents a premium or 8 cents a premium. So I'm going to say that 3.1 should give the better results in terms of oil sorption. So let's see if the magic works. And what did I say? 3.1 cotton should be much finer. So smaller the number in terms of millitex, it is finer. And then base range cotton are coarser, right? Immaturity is very high in 3.1 and cotton F is about 4.4. So the immaturity is less. And maturity ratio, you see even 0.01 makes a difference. If you are going and looking at cotton characteristics using AFIS, you will know that. So I'm not going to delve into that. These are all the results which I showed you how we do. What I showed you was motor oil, but actual crude oil is thick, viscous, fumigating, phase-changing liquid, which you see. And with this, we published in American Chemical Society, and that got international press. Okay, that's a different story. Now comes the results. So 3.1, each gram of 3.1 can absorb up to 36 grams, or it can take 36 times its weight. If it is 2 grams, then it will be 72 grams. Whereas the base range cotton will absorb 10 to 20 grams per gram. That's a lot. When you translate that in terms of ppm and in terms of the volatile gases it emits, it makes a difference. Even a gram absorption makes a difference, right? So I am paying a material 10 cents less. I'm finding a value to a material which the industry is not kind of to. That too, the applications are in healthcare and environment where the industry is willing to pay more. I'm reducing the cost of manufacturing by using non-woven technology. And that too, I'm not using an expensive spunlace non-woven technology. I'm using a run-of-the-mill, very mundane, low-cost production, needle punching. So the gifts keeps on giving. This trend is there. Finer the fiber, higher immaturity is there, high surface area will be there, and the per gram absorption of crude oil will be higher. There is a correlation between the coarseness and the absorption. When the fiber is coarser, say 175 millitex, the absorption is less per gram per gram absorption is less. Whereas when the fiber is finer with less millitex value, 150, the absorption is more, 37 grams. And we did BET surface area showing that finer cotton at 3.1 microner has higher surface area. Nobody showed result of individual cotton for BET because it's very difficult to do. And we will show you how. This is the first ever result, environmental scanning microscope, showing that low microner cotton with higher wax and fine structure first absorbs the liquid, which vaporizes quickly, but it absorbs the liquid and forms a biofilm. And when it forms the biofilm, imagine that we are talking about a phase-changing material, VOC, so it will evaporate. So it curtails the evaporation by absorption. Individual fiber absorbs, and the cotton serves as a crucible. This is at the micro level. Nobody in the history has done before our lab. Anyway, it's my students' work, so it's okay to brag the young man's work. So each cotton absorbs like a crucible and then swells instantaneously. Not only absorption happens, as you see the film, at individual fiber level, so the oil is held intact. What did I say? It's a carcinogen. So when you are able to hold the vapor, higher surface area material has higher absorption, so it can hold the vapor. And then the liquid phase of the material is held due to absorption at individual fiber level. Okay, so this is what happened. So absorption, and then it also results in capillary. We can reuse. Then question comes, what do I do with this material? I can reuse it. I can ring it. Okay, I can ring it, squeeze the oil, and then reuse it multiple times. Depends upon the weight and the thickness of the material, you can reuse it. So this is one of the first finding, that low microner cotton, due to high surface area and increased fineness, lead to higher sites for sap surface absorption. Absorption leads to capillary flow, which you saw, the formation of biofilm, and then subsequently at individual fiber level, absorption happens and you see the fine bulb structure. So this is what it is. We published this, and then because it was very pertinent, then okay, we showed it at the individual fiber level. Can we translate that into fabric? This is what I showed you. The thing what I have here is an actual production. So many needle punching machines are available, and then now I could show you. Can you translate this into a fabric level like this? Yes, I'm going to show you results. So this is how we did. We took that, I'm showing a laboratory thing, how we did as a batch structure. We take the flat mini card, just simply card it. We don't do any processing onto the cotton. From the bale, we take a low microner cotton bale, just pass it on and make a bat, and then like this. Then we do the same method, modified ASTM method, and you could see again, in terms, see, in crude oil, it absorbs roughly about 36 times. What did I say? Low microner cotton should have higher wax content. You can see that normally cotton has 2% wax. Here it is about 6 to 7% wax, right? So we found it across the spectrum that when the microner goes down, the wax content increases. In terms of crude oil, per gram absorption is 30 grams, whereas it is double. In terms of motor oil, it is twice because it is less viscous. But we have to only prove at the crude oil. And when you use a less viscous oil, the absorption keeps on increasing. Beautiful result. So we can translate this. The same concept happens if you have a finer fiber, even in the bat form, it is immaterial whether you are using a crude oil or a motor oil, absorption keeps on improving. First ever results to show, and then it retains. That's very important. So what happens if it, will it let the oil go? It lets the oil go to some extent, but there is a saturation level because I told you at individual fiber level, each fiber balloons and serves as a crucible, as a reservoir. So it will hold the fiber, and depending upon the type of cotton, the type of the oil you use, that saturation level happens. Okay. So this is what it is. Now, what I showed you is for individual fiber. Now I'm showing you at the bat level. Beautiful. Now the result is with motor oil. So you see much absorption. Beautiful bulbing happens at an individual fiber. Again, we published as part 2 in industrial, and this is what I told you. Beautiful result showing comparison between 4.4, 4.3 baseline, which is on the right side of mine, which should be your left-hand side, I suppose. And then I said that finer the fiber, it collapses. You see that fiber with no cellulose deposition. So there's no cellulose. So there's no way a dye could pick up or stay. So it collapses like a horseshoe structure. When it collapses, you can pack more fiber and higher surface area. Beautiful, beautiful result. So that's what it is. Crude oil sorption depends on the type of the fiber you use. Low microner cotton, finer cotton, high surface area cotton, and high waxy cotton. And this has, and we said that we could reuse it. Of course, we can use it for 10 to 15 times the same material. So not only the material is sustainable, the material is cheaper. What are the 3 concepts of sustainability? Reduce, reuse, and recycle. That's what it is. And we have shown that natural material, which the industry is not favoring, we are putting into a good use. That material can be reused depending upon how concentration of oil is, depending upon the spill, minimum 10. Of course, at each time we reuse it, the absorption capacity decreases. Then what do you do with this material? It's not a synthetic material, so there's no worry about microplastic pollution at all, right? Luckily, Angela gave me one of the last speaker here. So what all the previous people have been telling, I wanted to attack all those problems. Okay, sustainability is good. Sustainability at what cost? then you use a material which is sustainable, then how are you going to dispose it? There's no question of disposable issue at all. There's no question of microplastic pollution at all, because you take this material, dump it even in the seashore. What is this? This is cotton, and that too immature cotton. So it is going to collapse much more quickly. And then this material with barks and other vegetative material is going to be a natural food material, feed material for microbes, particularly bacteria. So the bacteria will feed on this cotton because of the vegetable matter there. And then the oil is a favorite material, food. It's a favorite food for microbes. So entire thing gets collapsed. Of course, it takes time. We showed that within 6 to 8 months. That's another study. For lack of time, I'm not presenting. So minimum in crude oil, each gram of low micron cotton absorbs 30 grams per gram. And if you just use different type of oil, ASTM only wants us to use non-detergent motor oil. It is twice. So there's no question of marine pollution, no question of contaminating the environment, no question of developing a sustainable material which is costly. Because we are raw material. See, in any textile product, we know that the raw material constitutes 60 to 70% of the cost. I'm reducing 10 cents at the raw material level. I'm reducing the cost of manufacturing because I'm cutting the manufacturing process. I'm not using a high investment needed machinery here, needle punching machinery, because it is one of the lowest investment needed in non-woven. So that is sustainability. Sustainability will be bought by the consumer. Of course, everybody wants sustainable material, no doubt about it, but cost. If you are able to produce a material and deliver it to a consumer at a relatively inexpensive, then there is you don't have to keep on pushing. There will be a pull, and that's what it is happening. And this, and more importantly, like Cotton Incorporated is doing, we have to tell a good story. And this story, because we proved evidence-based things, and everybody did so many. Okay, I took hemp, I took PLA, all are good, but they are expensive. So industry didn't want to touch it. The journalist will ask, okay, these are all good, science is good, but science at what cost? Even though we are telling that it is going to attack an important problem, human health and environment, there's only so much people will be willing to pay. But we were able to prove that we could do it at a very cost-effective way, and commercial within 5 years became Broad Street appeal, and so many things picked up. And you could see that Guardian picked up, economists picked up. So it's made, so science has to be relayed to an 8th grade student, to a common Joe Blow out there to absorb. So that's what happened. It's a good story. And American Chemical Society put this as a way to do research science backed by evidence, but you deliver a product, transition into a commercial at a relatively cost-effective manner, and this is available. And they also put this story, one of the other story, to US Congress as how the research has to go. Basic science accepted by peers. Of course, ACS accepted it, then translate into a product in a way which the consumer will buy its whole 360 degrees. This would not have been possible without the support of Cotton Incorporated and my program manager, Dr. Kader Ek, and producers. So we have to talk to the people. It's where the rubber meets the road. It's the producers. So they were worried, okay, nature, you cannot control nature, particularly drought, high drought like this year, 33% abandonment of cotton. What do? You're going to get these low micron cotton. What do I do? Okay, find something. So it's told a good story. So thank you. And I think I finished within time. If there are any questions, so this is what I've been asking everybody. Science is good, but science has to tell the story, and it has to come up with a product, if at all possible, at a way which the consumer, the stakeholders will buy it. But it took a while. Many of my products didn't come to this success. But one of the few, out of all my 25 years working with young brains like this, couple of products have been transitioned. And sustainability at what cost? That's what that AATCC and ACS should do. Sustainability is good, and it is part. We should do it as part of sustainable goals of United Nations. But we also have to work on other aspect of sustainability, the cost, energy, economy, and environment. These three things should sing the song in the same phase. Okay, thank you.
Thank you so much. Such a great presentation, and such a nice idea of using raw low microneedle cotton to tackle the oil spill problem. Thank you so much.